All right, hello everybody. This is going to be the tutorial video for section 3.1 to 3.3, day 2. We're looking at applications of one-step inequalities. So today is all about word problems, which is fun, right? I think it is. All right. Let's make sure that the pen works. I was going to write key for answer key, but I already uploaded that. Okay, well, at least we know the pen works. All right, so today's target goal, as I said, we're looking at how to apply one-step inequalities to real-world applications. The biggest thing in this section to be able to identify is what symbol are you going to use when you have to set up the word problem. Are you going to use greater than, less than, greater than or equal to, or less than or equal to? And so the first thing I did is I made you a little chart that has a lot of common phrases that you're going to encounter in these word problems. And basically, the phrase itself helps you decide what symbol to use. So if you're dealing with a word problem and they use a phrase like more than, greater than, or bigger, you're going to want to use the greater than symbol. If you see a phrase like less than or smaller, you're going to use the less than symbol. These two, I would say, are the more obvious ones. The ones you're going to have to study a little bit more and practice a little bit more with are these two in blue, because they don't necessarily just use the phrase greater than or equal to or less than or equal to. It's a little bit less obvious than that. Whenever you see the greater than or equal to symbol, the problem might use the phrase at least, a minimum of, no less than, or they might straight up just say greater than or equal to. More likely than not, though, you're going to see one of these three. Okay. And on the flip side, literally on the flip side, if you flip the symbol, less than or equal to, they might be nice and just say less than or equal to, but they probably won't. They're probably going to use a phrase like at most, a maximum of, no more than. We've already done problems like this in chapter 2 if you're on a budget. If you have a capacity or if you have a limit. These are all things that mean you reach a certain point and you can't go above it. Whereas the first one we did, greater than or equal to, means you have to hit the smallest value and then everything goes above it. You can't go below it. So let's start out with just scenarios. We're not going to actually solve an entire word problem. They're going to give you a one-sentence summary, and you have to create an inequality to model that situation. We're going to let X be our variable in the problem. So the first one says Tom has a budget of $100 for dinner. What that means is he can't go over $100. He only brought $100 with him. So his dinner could be $100 or less. My key phrase here is budget. Budget cues me in that it's less than or equal to. So his budget X needs to be less than or equal to $100. The second one says Jenna must run at least, there's my key phrase, 10 miles to qualify for the marathon. At least means the smallest she can run is 10, or she could run more. And if you think about it, if she only runs a mile or two, she's probably not going to qualify for a marathon, because a marathon, you're running 26.2 miles. Okay? They want to see that you can run a smallest amount of miles, and then you build your way up. So this would be greater than or equal to X. The miles needs to be greater than or equal to 10. Third one says Pat must buy a minimum of, there's my key phrase, I'm going to underline it, 10 computers for his company. Minimum of means at the very least, he needs to buy 10, but he could also buy more. So this is another key phrase for greater than or equal to. X is greater than or equal to 10 computers. Could be 11, could be 12, could be, well, I can't really do 12.5 computers, but 13, 14. Part D, you can spend no more than, I'm going to underline it, there's our key phrase, no more than $50 on video games. That means the highest you can spend is 50, or you can stay under that budget. You can't go over 50. So this is less than or equal to. Less than or equal to 50. Some of you are starting to probably drive soon, or you might be in driver's ed. This is a sign that you definitely should be paying attention to when you're on the highway, or the cops will stop you and give you a ticket. Speed limit, 75. You definitely don't want to use greater than or equal to for this one, because if you go over that amount, especially if you were young and in high school like you guys, you're going to get a ticket a lot easier than someone older. you can't go like 85 or 90. You're at 75. That's the highest you can go, or you can go under it. Okay. So limit, there's my key word in this one. I'm going to highlight it, means less than or equal to. Okay. That's my tip of the day for you. Do not speed on the local roads, and also don't speed on the highway. Last one says Al must clean his room for more than 30 minutes. This is the only one that we see here. It can't be equal to 30. It's got to be greater than, more than 30. Okay. So just to give you some scenarios to decide what type of symbol to use. Now we're going to actually solve entire word problems that kind of use scenarios like that. So the first one here says your goal is to take at least 10,000 steps per day. According to your pedometer, which is a tool you use to measure steps, you have already walked 5,274 steps today. Find the range of the number of steps you must still take to reach your goal. As usual with the word problem, skip the numbers. Look at the last sentence first. What are we finding? Range of the number of steps. Okay. And it's going to be a range because it's an inequality. It's not just going to be one number. So I'm going to let S equal my number of steps. Actually, S kind of looks too much like a 5. I don't want to make it confusing looking. Let's just use X. Nothing wrong with using X. Hey, key phrase they identify. This is what I would recommend you do with an inequality word problem. Look at the key phrase. It said at least. So I'm going to underline it. And based on our chart on the front, at least means bare minimum of 10,000, but it could be higher. You've already walked 5,274 steps. You want to know how many more you need to take. So you're at 5,274. You add on some more steps. We want all of those total steps to be greater than or equal to 10,000. So that's your setup. To find the range of steps, you got to isolate X. So I'm going to subtract 5,274 from both sides. 10,000 minus, let's do that on a calculator. That is 4,726. And we're measuring steps here. Okay. Our sentence would be, answer their question, the range of number of steps. So you must take, it's not exactly 4,726 steps. It's, here's our phrase, at least. Because if you look at the symbol, it's greater than or equal to. So you could say you must take at least, or you could say a minimum of, no less than. Any of those phrases would work. 4,726 steps. More steps. Let's do that. More steps. Okay, make sure you have a phrase that cues you in that it's greater than or equal to. Next one says you and 3 friends went to dinner and you were hoping to pay for everyone's meal using a $50 gift card. Write and solve an inequality to determine how much money each person's meal can cost, assuming that the bill is split evenly, so everybody's paying the same amount, and still only be able to pay using the gift card. So you have that $50 budget. If I look at the end, it asks me how much money each person's meal can cost. That's what we're trying to find. So I'm going to put C is cost of person's meal. That's what we're trying to find in this problem. Be careful. It's not 3 people. It's actually 4 people because it's you as well. So I'm just going to make a comment here. You actually have 4 people going out to eat. So you're splitting the bill 4 ways. And you have $50. That's your budget. $50 gift card in this problem means that you are on a budget. So I'm going to put that on the side. Whenever you're on a budget, something's got to be less than or equal to. And in this case, it's less than or equal to $50 because that's how much money you have with you. The cost of a person's meal is C, but there's 4 of you. So you're multiplying that cost by 4. Okay. So that's your setup for this one. And then to solve it, divide by 4. 50 divided by 4. Is a decimal, and it's fine because we're talking about money. It wouldn't make sense to change it to a fraction. So $12.50 12.50. Okay. That's the most that you can spend for one person. You don't have to spend $12.50. If you only want to order maybe an appetizer for $8, that's fine. But you can't spend any more than $12.50. Otherwise, you're not going to be able to just use that gift card. You're going to have to take out your credit card, your debit card, or your cash as well. So I would say here, the question asked, how much money does each person's meal cost? So I'm going to say each person's meal can cost, I'm going to use at most. That's usually my favorite phrase to use because it's the quickest. You could also say no more than. You could say a maximum of. Any of those phrases that I gave you in the chart on the front would work here. I just think at most is the most simple. So at most, $12.50. All right. And the last one we'll do together, and then I have a you try one that you can do and check with the answer key that I posted on Google Classroom. Okay. This one says you want to buy your mom a $40 birthday present. Recently, you have been walking dogs in the neighborhood for $6.50 per dog. Write and solve an inequality to determine the minimum number of dogs you can walk and still be able to buy your mom the present. Okay. So look at the last sentence. What are we trying to find? Minimum number of dogs. So I'm going to let D in this problem be number of dogs. Key phrase, I'm also going to identify. This problem said minimum. So that means I'm going to have some smallest amount of dogs I can walk, or I could walk more than that. And you got to have that in this case, because if you want to spend $40 on mom, you might have to spend more than 40. You're not going to spend under 40, right? It's your mom. You got to buy her a nice birthday gift. So something in this problem needs to be greater than or equal to, because it said minimum. That cues me in for the symbol. And what is going to be greater than or equal to? It's going to be the cost of the present. You know, you might find something that's exactly $40, but maybe it's 42, or maybe it's $45 or $50. You want to spend at least $40 on mom. In order to do that, you have to walk some dogs. Each one, you're charging $6.50 times the number of dogs. You're going to make a certain amount of money, and that's going to be greater than or equal to $40. So to solve this, I'm going to divide by 6.5. Notice I'm not multiplying or dividing by any negative numbers, so I don't have to flip any signs. That was our big rule from yesterday. 40 divided by 6.5 is, okay, interesting, 6.15 roughly. Now you need to think very carefully about this problem. This says right now you must walk at least 6.15 dogs. You can't walk part of a dog. Can you have half a puppy or 0.15 puppies? That doesn't make sense. Okay. So if you know this can't happen, you probably don't even need to write this, but I'm going to make a comment here. You can't have 0.15 dogs. You either have a dog or you don't. So if it has to be greater than or equal to 6.15 dogs, you have to think of the next highest whole number above 6.15. Can't round down to 6 because it's greater than or equal to. So you're going to have at least 7 dogs. You got to round it up. I'm going to put a comment here, round up. Okay. So D is greater than or equal to 7, which means to answer their question, how many dogs do you need to walk? You could say you must walk at least. You could say a minimum of. You could say no less than. I'm going to use the phrase they gave in the problem this time, which was minimum. So a minimum of. You do not have to use that phrase. You could pick one of the other ones if you like it better. But you got to have some phrase that cues you in what the inequality symbol was. A minimum of. Please don't write 6.15 dogs. You have to have whole number puppies. 7 dogs. And then you get to buy mom that nice birthday present. Start brainstorming what you're going to get her. All right, that is it for the ones I want to do with you. This one is a you try problem. So at this point, what I'd like you to do, you can end the video, try this problem out, check your answer on Google Classroom. Let me know if you have any questions on it. And your homework is Math Excel. All right. Have a good rest of your day.